this. So I think usually I get around 12 steps every semester. It's close to that. Don't hold me exactly to it. But then in Calc 2, you're going to double that list. So I'm teaching you what should I try first, what should I try second, what should I try third, etc. Right? All the way up to it doesn't work anymore, and that's when Calc 2 comes in. Our methods in Calc 1 don't work throughout Calc 2. We need new methods, right? And that's how you're going to start. So Calc 2 should be Chapter 5, easy. Chapter 6, difficult. Chapter 7, very easy. Chapter 8, nearly impossible. So it's going to go easy, difficult in Calc 2. So we had 3 steps so far. Our first step was, right, we know f prime. For example, the integral of minus 1 over x squared dx. We just know this one, right? What's the antiderivative here? Yeah, 1 over x, right? Or the integral of e to the x, right? That's e to the x plus c. And we need that constant of integration, right? So level 1 we know, right? We know the relationship between the derivative and the antiderivative. We just recognize it. Step 2 is a power rule, right? The antiderivative of x to the n dx. I'm doing this process for the power rule for derivatives, but in the opposite order with the inverse operation, right? So I'm going to add 1 to the power and divide by the new power. Step 3, or level 3, was our tricks. And we had a whole bunch of tricks. I might add to them. I said multiply by 1, add 0, divide and conquer, long division. I had a couple, right? So, for example, this looks an awful lot like the derivative for what? Square root of x, right? But I'm missing a 2, right? You agree? So I kind of want that. If I could put that 2 down here, I would have what I want. But I can't do that, but I can multiply by 1. So I'm now multiplying by 1 over 1. Do you see it? 2 over 2 is 1, yes? So when I do that now, I'm just focusing on the integration here. You can see I'm going to get 2 square roots of x plus c. Kind of that red 2 went along for the ride. Like a coefficient of 2 would go along for the ride for differentiation, it goes along for the ride for integration as well. That's what we've done so far. We're ready for a few new processes. I think I can do 4 today. You must practice, okay? So our practice is going to come from 5.5. Oh, Sonia, I'm sorry, I didn't get to your, did I somehow answer your question or? So thank you. I was so tired this morning. I went to McDonald's to order a coffee. I said I'll have a medium Diet Coke with 4 sugars and 2 creams. And they looked at me like, I meant medium coffee. I'm so tired. I'm ordering a diet soda with sugar and cream in it. Why? Why can't I log in? Why? Can someone open the book for me to section 5.5? Anybody get the book open? Can someone please open the book for me? You have it open? Will you get to the section 5.5 homework? It's easier to click on 5.6 and go backwards. I'm pretty sure it's going to be 1 to 55 or something like those. The 1 to 79 is like in section 5.5. I don't know why I can't. 79. So 5.5 suggested problems. One to 79. I should be able to. I might not get to number 75 today or 77, but I should be able to get you pretty far today. I plan on doing level 4, 5, 6, 7, 7, and then I only have a couple of little tricky ones left and inverse trigs, right? So, so here we go, level 4. This is our first of 4 or 5 processes called U-subs. So the very first U-sub is you're going to see F and F prime and you're going to change it into F of U du, which is funny to me. Sounds like I'm cursing a little bit. F of U. So you're looking for a function and its derivative. And there should be nothing else, right? So we're going to let U be f of x. And we're going to differentiate both sides the left side we're going to get du, and right side we're going to get f prime of x dx. Let me go back a step, okay? So I'm going to visualize a function and its derivative. I'm going to see it, right? And I'm going to let u be the function, and then I'm going to differentiate both sides. What do I get? I get du dx equals f prime of x, right? You with me? And these pieces that we're going to have here, or this piece that I'm going to have here is called a separable equation. So you'll be learning about this in Calc 2. But what it means is my du and my dx actually can be separated by multiplication or division. So I'm solving for du, and I finally get du is f prime of x dx. Can you kind of see that dx as a denominator piece, and I cross multiply it to get it to the other side? So that's what I can do when they're separable. All of our equations will be separable. Until the engineers go to differential equations, where you start talking about separable equations and non-separable differential equations, okay? So, but that's 3 semesters away, so, right? So this is strange, but I need process written down. Some of you still don't know how to find the absolute min or max on a closed interval. You find the values at the endpoints, you find the values at the critical, and which one's the highest, which one's the lowest. It's just you don't have it written down. It's not that it's difficult. It's not difficult. If I'm allowing you to put all the steps down, it's not difficult. Walking to California is difficult, but no single step is difficult. Now, there's a couple of rivers in a way, but and some mountains. So the whole process is difficult, but not if you have it written down step by step. Your formula sheet should be so packed with information on the final exam that you need a magnifying glass to read it, and I'm fine with that. You can bring a magnifying glass in, that's fine. All right, let's do one of these, okay? The integral of sine x cos x dx. Well, I'm setting you up for this level, right? I'm setting you up for you should be able to see a function and its derivative, right? So which one is the function, which one is the derivative? So fine, so we're going to let u be the sine of x. Now, I'm just telling you everything that's left over is dx, or sorry, du, but you should be able to differentiate this, right? What's the derivative of sine x? Okay, so du is cos x dx. And you see that's what we have. In green, we have du, right? And in blue, we have u. It's that simple. It really is that simple. So what does my integral become now? It becomes u du. And now I'm back at the beginning of my list again. Well, this is actually step 2, right? It's step 2 or it's step 1, either one. It's a power rule now. But now what's my variable in charge? What's the variable in charge now? Not x anymore, right? U. So I'm pretending the variable u is the variable x, just like at the beginning of the semester, right? So what's my antiderivative here? U to the 1, I have to add 1 and divide by the new and add a constant c. So that's u squared over 2 plus c. But u is sine of x, so I need sine squared of x over 2 plus c. And there's my antiderivative. What's nice about this is you know how to check it on Desmos already, but you're going to check it as if you're doing a differential, a derivative problem. So meaning this is your y equals, this is your f of x, right? And when you plot y equals f prime, you should get sine x cos x. Right? You know what I'm saying? So when you're checking these, you're going to check from the end. You're going to say this is your function. That argument should be your derivative. Does that make sense? I'll actually show you just so it's clear. So I got y equals sine squared x all divided by 2 plus c. But who cares about plus c for now? But if I put it in there, you can see it's just taking my whole function and moving it up or down, right? So the slopes all stay the same, yes? I'm most likely interested in 0. Let me call this f of x, though, sorry. And because now I want to graph y equals f prime of x and graph y equals sine x times cos x. And I want to see purple and green matching, right? Let's do another here. So this is still level 4. I want the integral of ln of x over x dx. Do you see the function and its derivative? Do you see the function? Sebastian, what's the function? Yes, so u is going to be ln of x. If I take the derivative of ln of x, I get 1 over x, right? So look at this in between step. Du dx equals 1 over x, which is going to give me du is 1 over x dx. So what I have highlighted in green is what? Du. And what is left over there is just the function u. So now I have u du, which again gives me u squared over 2 plus c. But u is the ln, so it's ln squared x over 2 plus c. Nice. Level 5. Ready? Not really. Not really. Didn't we take the weekend off? We took the weekend off? I hope you did. You deserve it. Right? I mean, I'm pushing you. You are ready to take, if you make it through the rest of this semester, you are ready for Calc 2 with any teacher, even the most difficult, which could be me. ln squared x. So ln of x times ln of x, almost like the way we treat sine squared x, right? Question? I don't know, and if they don't, they're, what did Elf call himself? What were they making fun of Elf? I forget it. Cotton-headed ninny-muggets, something. Nitty, I don't remember. Anyway, I don't know. I had so many students cheating from home that I just tried to, when we were doing COVID stuff, remote learning, that I just said, well, if they're gonna cheat, I can't stop them from cheating, so at least let me get them organized. And I say, all right, you can use notes, but 1 page. Have it all written out for yourself so you're not scrambling, right? Like open book test drove me crazy because I just hear everybody turning pages. And I didn't need to. I just practiced so much that I knew what to do, but I had no life, okay? So, but I couldn't stop students from cheating. I still find students cheating in the classroom anyway. But so I just said, hey, let me get them organized, and maybe it will help them get thoughts, together. So anyway, level 5, U sub inside. So our first U sub was a whole function. Our second U sub is going to be inside. Our third U sub is going to be a denominator. Our fourth U sub will be some combination of that with a leftover piece. And our fifth U sub, that will get me to level 8. It's kind of hard to explain, so let me wait for that one. But first level of U sub. So it's not something you recognize, right? It's not a power rule. You don't see any possible tricks you could do to it. So the next thing you're trying is, can I U sub with a whole function? If that doesn't work, then you're going, is there a clear inside? And you're going to U sub inside, right? So the integral of e to the 2x, or better yet, e to the negative x dx. So, do you recognize it? No. You would recognize it if it was e to the x, right? And maybe you could work it out backward in your head what it would be, but it's easier to just follow the process. So what is the inside here? Yes. So let u equal the inside. So for us, u is negative x. And then find du. Right? So du is what? What's the derivative of negative x? Negative 1, but then I need the operator dx. I'm now back to level 2. Actually, level 3. I need to manipulate this so I can make my U sub, right? I've got the dx part, but what don't I have? I've got the dx piece, but what am I missing? For my du, what am I missing to get the negative 1, right? So what I'm going to do is multiply by negative 1 on the outside and on the inside. So this is level 3, multiply by 1. I multiplied by a negative 1 on the outside and a negative 1 on the inside. Why can't I multiply something on the inside? Why can I do that? What is this thing? What is this? What letter does it look? What is it? It's a sum. It's the letter S. It's the integral. It's the sum of the area, right? So what allows me to put a negative 1 into it is just like me multiplying by a number into a sum, distributing. But what I do on the inside, I have to cancel on the outside, right? So when I'm multiplying into the sum, I have to divide by outside the sum. And in this case, multiply by negative 1 outside and inside gives me a 1, right? So now, look at what I have in green. I have a negative dx. What is that piece? That's du, right? So now I have negative 1 times the integral of e to the u du. And I'm back to level 1. Question? Yep, because I know they distribute in or out, so I actually multiply by 1. But I'm multiplying by what I need on the inside. I need the negative, and I cancel it on the outside. Yes, so the negative 1 that was on the outside is still there. The negative 1 on the inside became, with the dx, became du. See, the negative dx is du. Yep. No, that's what I want. This is what I want. Right. So that's what I have. This is what I want. Yes. So now we're back to level 1. What's the antiderivative of e to the u? Yeah. e to the u. It's just e to the u, right? Because we're now pretending x, our independent variable, is u subs. So I get the opposite of e to the u plus c, but u is negative x. So there it is, c minus e to the negative x. I don't know why so many of you are distracted with the phones and not writing notes. I don't get it. I know you burn out a little bit, but come on. Let's do another. Do you recognize this? No. Is it a power rule? No. Can I divide and conquer or long divide? No. Do I see a function and its derivative? Well, I see a sine function. I don't see its derivative. I need some kind of cosine function, right? So I'm going to my next process, which is inside, right? So inside is pretty clear there's an inside, yes? So u is 2x. du is, good, 2 dx. Yep, I need, so on the left side I'm saying, hey, the world is u. On the right side, the world is x. And since I'm doing derivatives, I need that d, that derivative operator. So du on the left is like a u prime. Dx on the right is like an x prime. So what do I need for du? I don't have it, do I? I don't have it. I'm so close. I have the dx. I need a 2, right? So I'm going to multiply inside by 2 because that's what I want. I want a 2 dx. And on the outside by 1/2. I must keep equality. I can multiply through sums with coefficients, like distributing, right? Not a problem to do that. So now I have 1/2 of the integral of sine of u du. Make sure you see that 2 dx became du, right? And the rest is sine of u. Well, I know how to integrate sine, right? I know how to integrate sine. It's the opposite of cosine. And of course, u is 2x. So we're on level 5. I've got 3 more levels of u subs. We'll do those tomorrow, Wednesday, right? And then I should be able to finish everything Friday. I'll be here Monday before Thanksgiving, but I plan on letting you work on your project in class. And then we come back from Thanksgiving. We have a Monday, I can finish off any material. Wednesday, review for the Chapter 5 test. That first Friday after Thanksgiving, we're taking the Chapter 5 test. And then we have a week of review and then the final exam. So we're running downhill. It's almost over. All right, yes, Daniel.
So go from sine, you look for the antiderivative?
Exactly, yes. So once we get to here, we're at level 1 again. Oh, I know if I take the derivative of negative cosine, I get sine, right?